Hey guys, how's it going? I'm GML Waffle and welcome back to another basic GML tutorial. Now in today's GML tutorial we're going to be going over basic collision, and I say basic collision but I actually mean sort of an intermediate level of programming in that collision. So it's not going to be anything that's going to go way over your heads as a beginner, but it is going to be slightly more difficult than the previous episode where we just did basic movement. So without further ado, let's go ahead and jump in. Just like last time, you'll notice I've already made up a sprite. I've called it SPR_wall. It's just a simple 32 by 32. I've created an object for it, and we won't be doing anything with this object. It's basically just going to be an empty object. All you need to do is make sure it's visible. Don't check solid, don't do anything else to it, just leave it. And you'll see in the room, I've gone ahead and scattered a few of them all around here, just for, a little testing purpose, so I don't have to go back and do it later. Alright, so if we go into our OBJ player, you'll see that we have the same movement code that we went over in the previous episode, right? So WASD moves blah blah blah. Alright, so now that we've got everything all set up and ready to go, we can go ahead and begin setting up our collision. So the first thing you'll need to do is add an event, add a create event, and add some code to it. Now we're going to declare two variables. Variable one is going to be vSpeed, and it's going to equal 5. The other one is hSpeed, and it's also going to equal 5. So that is the vertical and horizontal speed of movement. They're both set to 5, and you'll notice that our movement speed in our step event is 5 in every direction. So what we're going to actually do is just get rid of all of that. Just get rid of all of it. So now that that's all out of the way, we can actually go ahead and begin working on our vertical movement up. So using W. Alright. So the first thing we're going to want to do is say if place underscore meeting x, y minus our vertical speed, and the object is obj underscore wall, and then our brackets, and then we need to add while not place meeting x, y minus sine v speed in our obj underscore wall. And then we also need to add brackets to that. Y minus equals sine v speed. And then under here we need to add else y minus equals v speed. Okay, now that I have that all written up, I can go ahead and give you the rundown of what exactly each one of these lines of code does. This first line right here, if place meeting x, y minus our vertical speed, obj wall, is basically saying if we run into this wall to the top of us. So if there's an object called obj underscore wall directly above us, run whatever code is inside of here, inside of these first brackets. And then the second line here, while we are not, and that's what the exclamation does, it says not, it basically flips whatever you're writing. So while we're not in a place meeting directly above us, y minus sine v speed, and with the wall, then we're going to go ahead and move up that amount. Alright, so you're probably wondering what the sine means. Okay, so sine basically takes whatever value and it either assigns it as 1 or -1, right? So we are moving our y-axis up, which is negative, sine, and instead of moving 5, because remember we set vSpeed equal to 5, in order for us to get pixel perfect collision, it needs to instead be moving by either 1 or -1. So that's what this does. It basically changes the value of our vSpeed to 1 or -1, so we move up 1 pixel until we hit the wall. And then this else statement basically just says move. It's basically this same spot, but it allows us to reset our v-speed back to 5 after we come off of the wall. So what we can actually do is take all of this code, copy it, tab over, and paste. And then we can do it again here, and again here. Oh, that was a space, not a tab. Alright, now in the A, so we've gone from the y-axis to the x-axis, and I actually tabbed over too much there. So we've gone from y-axis to x-axis. All we have to do is change y minus v speed over to x minus h speed. Same thing here. Instead of y minus sine v speed, we're going to need x minus sine h speed. And x minus sine h speed. And x minus h speed. Okay, and it'll actually be easier if I just copy all of that and replace d with it, because then we can just go through and change all of the minuses to pluses. Okay, so in S, all we have to do is go through, because S is our vertical, all we have to do is change it to plus, so instead of moving up, we start moving down. Like so. And same for A. It should actually be D, because we replaced D with that. So all we have to do is go through and change all of the minuses to pluses. So we move right instead of left. So this requires no programming in the actual wall object itself. As you can see, everything is determined inside of the player object, so we don't have to write any additional code inside of our wall object. So we can go ahead and close all of that, and if we hit run, you'll see that we now perfectly collide with all of the walls. We can shoot the gaps, but we can't move up or down. There's no overlapping between you and the wall, because it's pixel perfect collision, so you're never going to go over the wall or under the wall. It'll always be perfectly in line. So there you have it. That was our basic collision, and I say basic, but it wasn't so basic. Anyhow, that was our basic collision tutorial. I hope you guys enjoyed it. If you did, be sure to smash that like button and comment what you thought down below. Don't forget to subscribe for more awesome tutorials, and as always, I'll see you guys next time.